Same function, same math, O.x plus O.y, same 5 million calls both times. One run finishes in 6 milliseconds, the other 28. Nothing about the code changed. So what did? The shape of the object you passed in. Same keys, different order, and the engine treats them as two completely different kinds of object. By the end of this, you will know exactly why and how to never pay that tax by accident. It quietly compiles your code to machine code and sometimes throws it away. Today, V8, the engine underneath every line of JavaScript you write. Here is the whole idea. Every function starts on the main road. Read one instruction at a time. Slow, but always correct. A crew stands at the roadside watching what kind of traffic goes by. See the same kind of vehicle enough times and the crew pours a shortcut built for exactly that traffic. No detours. But the shortcut is a bet. Let a different vehicle onto it and the crew cannot risk it. They tear the shortcut up and traffic reroutes while they figure out what changed, since talks and blog posts use them. The main road is ignition, V8's bytecode interpreter. The crew watching traffic is the profiler, counting how often each function runs. Pouring the shortcut is the optimizing compiler, TurboFan, compiling straight to machine code. And ripping it up has a name too, deoptimization, the bailout back to safety. Every call starts here. Your function runs through ignition. Correct, byte by byte. The profiler counts every call, watching for hot functions, the ones worth the investment. Cross the threshold and TurboFan compiles a version that bets everything stays the same type, the same shape. That bet is what makes the fast path fast. Break the bet and the optimized version gets thrown away, back to ignition, while V8 relearns. Here is that throwaway live. Call add on numbers 5 million times. TurboFan compiles it, betting on plain integers. Now call it once with a string instead. This is real V8 output, not a dramatization. Bailout. Reason? Quote, not a SME, unquote. V8's own word for a small integer. The optimized machine code for add is gone, thrown away, on purpose the instant its bet stopped being true. Your turn. Remember the cold open? Array 1. Every object built the identical way. Same two keys, same order every time. Array 2. 8 different builder functions, each inserting one extra tag before x and y. Pause. How much slower is array 2 really? About 4.5 times slower. Here is why. V8 tags every object with a hidden class based on its shape, the order its properties were added. One shape compiles to a direct fast lookup. A handful of shapes and V8 still copes. Passed about 4 different shapes through the same call site, V8 gives up and falls back to a slow generic lookup. That is megamorphic. This is not a toy problem. Parse a record from an API and depending on which fields exist, you add properties in whatever order they showed up. Every differently shaped record is a new hidden class. Your hot processing function drifts toward megamorphic without you writing a single bug. The fix is almost embarrassingly simple. Build every object through one constructor or one factory. Same properties, same order every single time. Fields that might be missing, default them to null. Do not add them later. And this is not the prototype chain from episode 4. That is inheritance. A hidden class is the engine's own bookkeeping, one layer lower. Boss level. 2 objects, same final keys, x and y, nothing else. One is built plainly, x, then y. The other builds x, y, and a third field z, then deletes z. Pause. Same keys either way. Same speed? No. The deleted version measured roughly 8 times slower. Deleting a property does not restore the old hidden class. V8 drops the object into a slower dictionary-style mode, permanently. Same final shape on paper. A completely different object underneath. Never delete on a hot path. Set it to null instead. Your field guide. You assumed JavaScript just interprets your code, line by line. Hot functions get compiled to real machine code. You assumed once optimized, a function stays fast. Break its bet on types or shapes and it is deoptimized, thrown away. You assumed the same final keys mean the same speed. Insertion order and history decide the hidden class. And you assumed deleting a property is harmless. It permanently downgrades the object. V8 does not interpret forever. It watches, bets, and compiles your hot code to real machine code. And the instant that bet breaks, it throws the compiled version away and starts over. Keep your shapes and your types boring and consistent, and the optimizer stays out of your way. Next Tuesday, the optimizer just built all that fast code. So what happens to the objects it no longer needs? Garbage collection, and how V8 decides what dies. Subscribe so it finds you.